Can you able to see the screen?
Yes.
Okay. Okay. See, first of all, we should know we are all talking about database administration, especially Oracle database administration. For that, what is the base? The base is database, correct? And I already told that in the demo, it was become very popular globally because of its varied features, correct? So, keeping that in view, we should know the basics of this database administration, and for that, we should know what is database management system, and before that, we should know what is database and what is actually data. Okay, without data, we don't get all these concepts. Okay, data is again a collection of raw facts and figures. Okay, so it can be like if we have any diagrams, or if we have any text document, any kind of text, and whether your audio file, whatever it might be, those collection of these facts and figures, we call it as data. It's in raw form. Okay, that is the first definition given for data. Okay, and here there are two types of data we have: structured data and unstructured data. Okay, here in the structured data, say for example in an enterprise or in a company, we call it as employee number, a unique number given to any employee in a company. Okay, so employee has an ID, nothing but employee number or employee ID. Okay, and e name or employee name, address, phone number, city, location. These all comes under structured data. Why we are calling it structured data? Because it carries some meaning to the end user while we are pronouncing that word. Okay, if we say that word, we can able to correlate. Yes, this is related to employee number, yeah, e number or empno. Or if I say e name, means employee name. Okay, that we can able to find it out with the word that we utter from our mouth. It's called structured data. Then what is unstructured data? All your video files, audio files, your other XML data, or any data that we are getting in the internet today from social media, anywhere, on the data that is generated from the machine generated data, or images, etc. These are all comes under unstructured data. You understand the difference between structured and unstructured, Rehan?
Yes.
That is how we segregate. Data is of two categories: structured data and unstructured data. So all the commercial databases today, what so we are calling about Oracle, SQL Server, DB2, MySQL, Sybase, Ingress, Postgres, etc., etc. All these commercial databases, they deal with structured data only. Okay, unstructured data, it is not possible to handle. Say for example, there is other category called semi-structured data. Okay, and which is via media between structured as well as unstructured data. Okay, and here there small images or the audio files. We are trying to store it in the commercial databases in the recent versions. So actually, The structured data will be taken care by the commercial databases like Oracle and other database vendors. Whereas unstructured data, there is in the market more than 85% we have is unstructured data. Structured data, we are able to give solution. We means the commercial database vendors like Oracle, Microsoft, IBM, Hyperion, other database vendors, they are able to give the solution for the structured data only past few decades. Whereas this unstructured data is keep growing past few years, like 5 years or 6 years back. So for that, what is the solution we need to give? Because of that, the data is growing enormously, which we call it as big data. Big data is a problem, and for that, we need to give a solution, which is Hadoop. Hadoop is the solution, big data is the problem. So all the unstructured or semi-structured data can be handled easily for processing by Hadoop. Hadoop is a framework which is an ecosystem which has many different components, which is especially meant for unstructured data. Nowadays, it is keep growing very much. Okay, did you follow?
Yes.
And what we are handling is for structured data, where all commercial databases are being taking place and to start working on that. Quite few decades, we have a solution for structured data. So recently we have the solution for unstructured data with a solution called Hadoop. So our training we focus mostly on structured data, not on unstructured data. Is it clear? Is it clear for you?
Yes, yes, Sham, but I have one question. What about blob and clock
Yeah,
fields?
yeah, yeah.
It can use.
I saw your message. Yeah. See, we can also include that. Okay. But there are certain pure unstructured data. Okay. So those cannot be handled with the normal or traditional database management systems. So for that, a separate category or separate infrastructure or separate frameworks are required for that, which we call as Hadoop. For small blob and cloud, we can add, whereas there is massive amounts of data keep growing from different sources of data. So for that, these structured database systems or databases cannot handle those unstructured data, which is cropping up petabytes of data per day from different sources of data, you know. So around the world, not only from one place. So for that, we need to go with a different strategy solution, which we called as Hadoop. We have blob and cloud that only will store small images up to certain extent, but not all. Even once we store that, we get a lot of other performance issues. There are certain limitations for that. Okay, I don't deny we can do that, but only with a very few limitations. Okay, sorry, very few limited features. Is it clear? Okay. Next, here we understood what is data. Next, generally we used to call data information interchangeably. We use those words, right? But in real time, they are not same. Data is different, information is different. Okay. What is the difference? As we already know, data is nothing but collection of raw facts and figures which contain meaningful data and no meaning at all. So what is meaningful data? So here I am saying structured data, it contains a meaning, right? When I say a EMP number, you are trying to correlate with your employee ID or oh, it is employee number. If I say phone number, yes, it is a number given for any phone connection. If I say address, yeah, it is the address of a person. So it is trying to convey some meaning to the other person who is trying to analyze that. Correct? It is a meaningful data. Structured data is a meaningful data. What is no meaning? Some unstructured data have no meaning. It can be in any form. Data can be in any form. It is not guaranteed that all the data is in the structured format. Okay. So that is the reason whatever unstructured data we have, it doesn't have any meaning. That's the reason we segregate as meaningful data and no meaning data or no meaning at all. So keeping that in view, we try to frame a definition for the word information. What is information? Collection of meaningful data. It's not collection of simply data. Collection of meaningful data means your structured data. You are collecting structured data. That is called information. Clear? Difference between data and information. These are all the basics we are trying to discuss here. We are trying to learn because these concepts are very important for any DBA. Okay, that is the reason we are going from the ground basics. As I already told you, we should talk from the ground basics. Then only it will be easy for you to understand any DBA course, and moreover, it will be a foundation for your DBA career. Okay, that is the reason I'm talking about the basic. This we learned long back in our schools and colleges, the basics of databases. So just I want to reiterate the same so that we will be easily understanding the DBA course. And also, while taking up this DBA career, it will be a very easy for you to follow the next level sessions. So next, what is database? Database is nothing but organized collection of information. So we know data, next we know information, then database is organized collection of information. So that means we are setting certain standards for the structured data. Indirectly we are saying nothing but that we are storing in a common place, which we call it as database. Database is collection of organized information, or in simple terms I can say organized collection of information. Clear? Next, what is DBMS? Full form we know, database management system. It's very simple, but we should understand what DBMS will do, what are its properties, what is its nature, etc. DBMS, it is a system, or you can say, strictly speaking, a file system which we use to insert some records into the database and to modify the existing records in a database and delete the unwanted data or simply purge the data. These are all operations we do generally in a database. We insert the records, we insert the data into the database, and once inserted, if you want to make any changes to the existing data, we do it. We change the data with the new data, or we modify the existing data and we purge the data. Purge means delete. We delete the unwanted data. These are all the operations we do in a database. So there is certain file system, certain commands are there. Select, insert, update, delete. You know these commands, right? Okay, good. So these commands we operate on the database. So which we call it as a file system. Why we are calling file system is because there is certain process predefined in order to use the database, which we call it as database management system. Did you follow? Okay, good. Any doubts, you can please ask me. Okay. Next, we should know, we understand what is DBMS. Next, we should know what are the disadvantages we have with the DBMS. First, we have the problem in terms of performance. Next, redundancy. Redundancy means unwanted data or repetition of the same data again and again is redundancy. And there is a problem in null values acceptance. It is not able to take the null values properly. And there is no proper security defined or security controls in the DBMS. And we could not able to join the tables. Actually, what is a table? A table contains rows and columns with some data, correct? So if we have multiple tables, to extract the data from multiple tables, we will join the tables. But we could not able to do in DBMS. So these are all the disadvantages that we have in DBMS. First, performance problem, redundancy, null values are not properly accepted, there is a difficulty, and there is some insecurity in the system, and we could not able to join the tables to get the respective output from the database. So keeping all these disadvantages in view, in 1970s, Dr. E.F. Cott, he proposed 12 rules. Okay, he said that any database in this world, excuse me, he said that any database in this world with which satisfies these 12 rules, okay, can be called as RDBMS. Previously we called as DBMS. Now he said that in 1917, from 1960, in 1960s we had a problem with these databases, and these are the main disadvantages we used to have. And in 1970s, after doing lot of research for many years, he is the scientist, Dr. E.F. Cott. He is called as the father of the database management system or databases. And he is an ex-IBMer. He worked in IBM, and he proposed these rules. And he did a lot of research on these issues, maybe on these problems or demerits or disadvantages, what we call these five on this, and he proposed 12 rules. He gave solution for these problems, and he said that any database in this world which satisfies these 12 rules will be called as RDBMS. R means here relational. It has come from relational algebra, from mathematics. Okay. So he applied some mathematical rules on these problems, and he came up with some solution, which we call it, which he used relational algebra, mathematical. So because of that, he take that word relational and he added that to DBMS, which we call it as RDBMS. R was prefixed to DBMS. Previously we are talking just DBMS, correct? Now it was called as RDBMS. R means relational. Relational is the keyword which has come from relational algebra from mathematics. That's the reason it is a mathematical background. Is it clear? Okay, good. Next, we'll see what are these 12 rules which God was proposed. Okay. First rule is information rule. What is information rule? This rule says data should be stored in the form of tables. Okay. So already we know what is a table. A small block which contains rows and columns. In that we store the data. That we call it as a table. We know Excel sheet, right? Microsoft Excel sheet. In that, how it will be there? Like we have multiple cells, right? We have in the top horizontally we have A, B, C, D like that, right? The column names. And left side we have again series of numbers 1, 2, 3, 4, 5, 6 like that. So whenever we type anything in the Excel sheet, we type it like horizontally or vertically. We fill the data right in the Excel sheet. Similarly, we have the table. So that remember that Excel sheet in mind. That's nothing but a table. A format in a table is like an Excel sheet. A simple example is your Microsoft Excel sheet. Is nothing but a table. Why I am telling all this is because we should able to easily follow for a layman also. That is the reason I am giving the example of Microsoft Excel sheet. So we store the data in the form of tables, means rows and columns we have, so we store the data. That's what the first rule says, information rule. Next, previously we had a problem, right? Null values. So for that there is a solution, systematic treatment of null values. So null values were being addressed in a proper way with this rule, with rule 2. Okay. Next, comprehensive data sub languages. So we have DDL commands, we have DML commands, we have DCL commands, and we have TCL commands. I given the abbreviation for all these. DDL means data definition language, DML means data manipulation language, DCL means data control language, and TCL means transaction control language. I believe you know all these, correct? What are DDL commands, what are DML commands, DCL and TCL, right? You are aware of it? Okay, good. So all these commands were being introduced as one of the rule. Okay. Next, data distribution rule. What is data distribution rule? This rule says distribution of data from multiple systems for multiple users. We have different computers across the globe, say for example, and there are n number of users, maybe hundreds or thousands of users are being accessing the data. So they can access the data from different systems spread across geographically. So the database should be able to cater the needs of the users with the data distributed in different systems geographically. That's called data distribution rule. Means data is distributed in different computers across the geography and will be accessed by different users who are spread across the geography. Systems are spread across, excuse me, and also the users are spread across. Excuse me, I have a sore throat. I apologize. That's what data distribution rule. Data is distributed across the different systems in different locations and the users are spread in different locations and they are trying to access the data from multiple systems, which we call as data distribution rule. So the database should be capable of handling such massive requests from multiple users spread across the geography, and also the data is distributed from multiple systems. Okay, this is data distribution rule. Next, high level insert, update and delete. So that means we could able to insert the record, we could able to modify the existing record, and we could able to delete the record or data. In other terms, in a layman terms, I can say we could able to push the data into the database, means insert the data into the database, and once we insert, we could able to modify or change the existing data on need basis, which we call it as updation. Okay. Next, we can also remove the unwanted data. That means deletion or purging or purge. All mean the same. So that all we can do with the fifth rule, which they are calling as high level insert. We can do a lot of other advanced operations as well. In order to address the disadvantages of DBMS, Dr. E.F. Codd, he proposed all these rules and regulations, and he said that any database which follows these 12 rules will be called as RDBMS. Okay, so we completed 5 rules. What is the next rule? Data description rule. What this rule says? Here we could able to describe the table definition, and the respective columns present in the table. What is a column? A vertically separated different columns, we call it as a table. Horizontally separated, we call it as rows, horizontal line of data. We have columns and rows. Okay, so we could able to describe the table and the columns. That's what data description rule says. We should able to do that. Next, data integrity rule. What this rule says? We could able to combine the tables with the help of joins. Joins is a concept with which we could able to combine multiple tables and we get the data. That's called data integrity rule. There is also one of the disadvantage, right, in DBMS. Here, no possibility to join the tables, null values acceptance, all this. So, yes, correct. So next is logical independence rule. What is logical independence rule? Say we have our database, and in that we have tables, and the table data is distributed in multiple systems. Okay, and whenever the user is trying to hit the database or hit the table and querying the table to get the data, the user will not be known from which system, from which location the data has been pulled out for them. Okay, so it doesn't make any change for the user. The user sits somewhere remotely and they want the data to be displayed on their screen, because the user are nowhere concerned from where the data is coming, whether it is coming from multiple systems or single system. It's nowhere affected. But the logical changes of the data, which the table, say for example, we have a very big table which is distributed in multiple systems, and whatever changes we make to the table data, it will not affect the end user's request. The end user will get the data as the user requested. That is called as logical independence rule. Physical independence rule means which is distributed in multiple systems. The data has been distributed in multiple systems, and whether it is getting
Excuse me, Sham.
yes.
Sham, can I have an example for logical independence rule? Can you give me one example, please?
Sorry.
See, this is a logical independence rule. The user client shouldn't get affected changes in the table data location. Means somebody is want to access the database in China, suppose. They
Yeah.
can have their own language to see this one. Okay,
Yes.
the data. Am I right?
Yeah. Yeah. And
This
here the table data, it is what is say distributed in multiple systems. The same table data. Okay, why we do that is it's called partitioning concept. Because of the performance issues, the table is distributed in multiple systems so that all the table data is not in one system. So that while retrieving the data, it will be very fast. So that the load on the particular system is not overloaded. The load is distributed while for querying, load here means to query that it will take more time, right? If it is in one system, if it is in multiple systems, the same data, sorry, the same table, then it will be easy for the retrieval from multiple systems. That's called logical independence. The table is one, but the table data is distributed in multiple systems. That's called logical independence.
okay. Thanks.
Okay. So if, say for example, you have 10 GB of data in a table. So the 10 GB instead of putting in one system, we are putting in multiple systems so that 3 GB, 3 GB, 3 GB or 4 GB another one. So the when we are querying the particular table, the load will be not only on one, so it will be equally distributed for getting the data. So the end user doesn't know whether it is getting from one system or two systems or 10 systems. The user requested, they are getting the data. So whatever changes you make logically by different concepts like partitioning or other rules of database what we are applying, so that is nowhere connected to the end user. They want the data. That's how you design your database by distributing in different systems the respective data, which is called as logically we are distributing data with the help of partitioning. Partitioning is a concept in Oracle where the data, the table data can be distributed in multiple systems for the faster retrieval of data, for the better performance. Got it? That's where your logical independence rule. Here we tell, right, there is a performance problem. Got it? In the DBMS? Okay. So that's the reason we are talking about the logical independence rule. Next, physical independence rule. Excuse me. This is also almost same, but it depends not on the logical side, on the physical side. The data is distributed to different systems in different hard disk. Okay, we kept in multiple CPUs systems, and the user is trying to retrieve data, but the user doesn't know from which server the data is coming. It is nowhere connected. We have 10 servers, our table is very big or our data is very big, so we have different tables, 2 3 tables he is trying to query. Maybe the 2 3 tables are very big, maybe 10 GB or 20 GB or 30 GB, which is distributed across the systems and in different CPUs, hard disks. Then the user is nowhere bothered from where we are getting the data. Okay, it is our responsibility to make sure that it follows that particular rule of code, which is physical independence rule. Our database should have that feature, should able to give the data as per the request of the user wherever the data is located. Okay, next, rule of guaranteed access. Rule of guaranteed access means while we are retrieving the data from the table or from the database, there should not be any confusion in the sense whatever the request has been made by the user to get the for the respective data, they should get the data as per their requirement, as per their need. There should not be any confusion. So whatever the data is requested, they should get the exact the same data. There should not be any discrepancy in giving the data from the database. If the user is asking, say, employee number 10 record, it should not give employee number 9 record or 8 record or 11 record. It should give exactly the record number 10, whatever the user is requesting. Okay, so that's what we mean here. There is not be any confusion. Exactly whatever the user requests, they should get the exact similar same data as per their need and requirement. We should not give the other data, whatever the requested data, other than that. Is it clear? That's called rule of guaranteed access. Okay. Next, view updation rule. So in the database, we have the concept of views, simple views, complex views. Simple views means we are trying to retrieve the data from the single table. Excuse me. So we are trying to get the data from the single table by creating a view. It is a mirror image of a table. Okay. So the end user doesn't know whether they are getting from the view or from the table. So it is a mirror image of a table where view does not store a data. Okay. It's only a temporary screen where acts as an interface between the table and the user. So we're trying to get the data. So simple views, we try to get the data from the from the single table, which is called a view. And once we try to update the table via view, it should do properly. Okay, that will be done. Through view, we could able to insert the record, we could able to update the record, existing record, or modify the record. There are other concept called complex views. Means we are trying to get the data from multiple tables. Okay, and we create a view for that. And the user try to access the data through view. So if the user will trying to access from multiple tables via view, also they should get the same kind of output. There should not be any confusion or any discrepancy while giving the data to the user. So all these are been properly addressed. Okay, that's called view updation rule. And here there is a small problem in complex views. So maybe in the coming versions, Oracle may try to retrieve, complete the, give a solution for that. There is a little slowness in complex views updation. So that need to going to be addressed in the coming versions in Oracle. Okay, that is the one rule where it satisfies 50% by Oracle. Okay, next, non-subversion rule. I will talk later about this once we complete those rules. Next, non-subversion rule. Here we are getting different versions, right, in Oracle database. I started working from 7i, 7.1, 7.3, 7.x, 8, 8i, 9i, 10g, 11g, not 12c. So the database should be capable enough to go to higher versions. The database engine should be designed in such a way it could able to take the new features and add new versions for that, which is called as non-subversion rule. Like this, 8, 9, 10, 11, like this. It should able to do the version upgrade. That is also possible. So these are the 12 rules. And he said, and there is a separate national body in US, ANSI, American National Standard Institute. It is in USA. It's a body with group of high-level professionals, American National Standard Institute. So, uh, what is this character encodings? Yeah, it can do all that. You can do pattern encodings. That's not a problem. Okay. So this ANSI, American National Standard Institute, it said that after reviewing all the 12 rules, any database, if it satisfies minimum 6 rules out of 12 rules, out of 12 core rules, if it satisfies 6 rules minimum, then we can call it as RDBMS. Excuse me. So he said 12 rules code, then ANSI took that initiative and it proposed, they considered COD's all 12 rules, and he was given PhD and he was given very good esteem importance, and he was called as father of the databases. And ANSI took that initiative, and they said that any database which satisfies minimum 6 rules out of 12 core rules, then we can call that database as RDBMS. R means relational. I told right, R has relation has come from relational algebra. Okay. So there are different commercial databases, right? Oracle, SQL Server, DB2, MySQL. So these are all commercial databases. Oracle, Microsoft SQL Server, IBM DB2, Sybase, MySQL, Informis, Postgres, etc., etc. Out of all these, Oracle is the only database which satisfies 11.5 rules out of 12 rules. What is that 0.5 rule which was not satisfying is view updation rule. In that, simple views, complex views are there, right? I told you. Simple views it is able to do perfectly. Complex views, there is some small problem. It is giving some little, slowness in terms of this multiple view updation. Because of that, the 0.5 rule was being kept, and except that it could able to do all out of 12 11.5. This is the only database which is satisfying maximum rules, and SQL Server it satisfies around 7 to 8, and IBM DB2 also same 7.5 to 8.5 or 9, and Sybase these are all very less in number, but they are all satisfy minimum 6 rules, 6 to 9, not more than that. But only Oracle is the database which satisfies 11.5 rules after 12 out of 12. It's really great. That's the reason this became very popular globally. And as I told you, more than 88 to 90% all the clients, all production systems, they are on Oracle. Okay, very few on excuse me, very few on other databases. All production systems and in all domains, this has become very popular because of this varied features of Oracle database. Is it clear? Next, finally, every SQL statement it should end with a semicolon. Every statement must end with semicolon. This is one of the important points that we should do. Whatever query we are writing, we should terminate with a semicolon. If we give, say, select star from EMP, EMP is nothing but table name. Say, for example, select star from EMP, and you have to give semicolon and hit enter key on your keyboard. Then only it will give the output. If you don't give semicolon, and if you hit enter key on your keyboard, it will not give the output. It will go to the next line. That's all. Because the database engine it doesn't know whether the statement got completed or you are trying to give some more. Got it? You are trying to enter one more line or one more command in that, or the same command is adding some more query in that. That's what it thinks. So that is the reason if you have completed your query, end with a semicolon. Okay. So this is about the basics, okay, that we should know, or a database administrator should know before going forward. Is it clear? That is the reason I want to take the basic ground level. No one will teach all this. This already we learned in our school and colleges. At that time, we didn't properly focus on that. Correct? Now we are trying to look into those concepts. So this will be a definitely a base or a foundation for your DBA career, definitely. So if you are constructing a building, first we'll put a foundation, right, with all the granite stones, and we then on that we construct a building. Correct? So if your base, if your ground is strong, if your foundation is good, then we can construct multiple stores building on that foundation, on that base. Am I right? Similarly, if your base of this database basics is good, then you can build your DBA career with flying colors. So this will be a permanent base for you if you understand these concepts thoroughly for your DBA career. Is it clear for you?
Yes, Shyam, it's great actually. I have one question regarding rule 2.
Yes, please.
That is nulls value are mandatory. Means we are
Yeah, yeah,
going
yeah,
not to
yeah.
allow user to
Correct,
enter
correct.
null values.
Yeah, yeah. I got it. Here, why we made it mandatory is first rule is mandatory information rule. Second rule, systematic treatment of null values. This is also mandatory. And finally, data integrity rule. This is also mandatory. You see three mandatory correct points here.
Yes,
Why we gave three mandatory means ANSI suggested six rules, correct? Minimum six rules
yes,
for any database to be called as RDBMS. Out of these six rules, these three rules are mandatory. Without these three rules, if you say any number of rules, they don't consider it as RDBMS. Out of that six
great.
rules, these three rules should be there, must and should be there. Okay, then only they will call it as RDBMS. You got it? Okay, okay, great. So this is about your DBMS or the base of your DBA career. People who understood this thoroughly, they will enjoy your DBA course like anything. Now you have the entire bird's view of your database structure and its implementation. It will be easy for you. So
One
main,
more question, Shyam.
yes,
This
please.
is related to logical. There is a rule, okay, that the logical partition,
Logical
okay.
independence.
There is a yeah, logical independence rule. Okay, fine.
Yeah.
Is it related to the character encoding? Means a
No,
user is
no, no,
accessing
no.
somewhere in some other country.
No, 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 no. It is nowhere connected with character encodings. It is only connected with the distribution of your data table. We have, say, for example, a big table which contains 50 crore records. Okay? Not 50 crore, at least 10 crore rows. Okay? A table
Yes,
contains 10 crore rows. 10 crore, you are able to follow. So then it is very huge big table which is difficult to access in terms of performance. So what we do is we try to create a partition on the table. So the table partition is distributed in multiple tables. Multiple tables in the
okay,
same table name. The data in the table is distributed 2 crores, 2 crores, 2 crores like that, different five partitions. But table name is
great.
same. But the data in that is been distributed logically. You got it? Whenever the user
Yes,
requesting, they request with the same table name for all the five partitions. But the user doesn't know whether the data is partitioned or unpartitioned. They are nowhere connected. They want to get the data, that's all they will get the data. It is nowhere connected whether the data is being partitioned or it is being stored in a different server or it is being located in a different geographic location. It's nowhere connected. The end user doesn't know, right? They will give a query and they expect the result on their screen. That's all. It is the responsibility of the database person how to give the data with good performance, with very fast giving the data to the end user. Whenever the user requests, they should get the data output immediately. So for that, if it is a huge data, if we predict, yeah, it takes more time, then try to go with some performance tuning topics. This will be done by the developers, not by the DBAs. These partitions, all that. Okay, but a DBA should be aware of this concept. No need to know all this, how to do all that. The developers, PLSQL, SQL developers will take care of this. But being a DBA, we should know. DBA is at a high level position. I told it, it's like equal to a manager in a company. They what they called, they rule the entire enterprise data. So they are the decision makers in terms of data management. So that is the reason they should know outline in a bird's view what is going on in different places of database. Is it clear? Okay. So any more questions before we close for the day? Just a minute. Just a minute. I'm getting some call. I'll be on mute, please. Uh, 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 Hello. I'm back. I'm sorry. I got a call from my office, Rayan. Uh, So I'm done for today. Okay, you don't have any questions, right? So we'll have it in the next session. Okay. So tomorrow, after tomorrow, I cannot take the class. I'm in an audit, right? So we'll have after 2 days, Rayan. Okay. Just expert. I mean, online expert people will update you. Okay. So tomorrow after tomorrow we don't have any class because I have to complete my audit as I told you. So today and tomorrow it will take more time for me in the office. Okay. Anyway, I will send this recording to what do you call this online expert people. They will send to you. Okay. Then see you. Uh, Take care. Bye. Yes. Yes. Yeah. Thank you. Thank you very much. Have a good day. Bye.